showed you how to get quick started with coding physics simulations in Desmos. What I wanted to show you today is how to do it in a way that allows you to add other features on top of the simulation besides just a particle that moves. And one of the things that you're going to have to do is, last time when we were writing the function that describes the motion for some, it might look like this, where we have some time parameter that moves, some parameters that describe what the motion is, and then we'd need to create a point. And so here, when I hit, I'm going to set the time to run from 0 to 10, as I did last time, and then this thing will accelerate. And so one of the things I'd like to show you how to do is how to make this object leave a trail of its motion along the way. That's called a motion diagram. The way that I do this involves changing the way that we write this, and instead of being in terms of the parameter t, we're going to define a function explicitly as a function of t and use t as a dummy variable, and let the actual value of t that runs the simulation be the subscript t final. And so if all I did was this, it really makes it look quite the same. So there's our particle accelerating to the right. What it allows me to do, however, is to create a different point. This point I'm going to label as x sub n for the motion diagram. Oops, sorry. It still needs to be a function of f, but I'm going to sort of be plotting it not at the time that the simulation is at, but the time, other times of interest to me. And so when we're making a motion map, typically what we're doing is we're interested in seeing where the particle is at different times. And so here in purple, you can see here's where it was, here where it was, here where it was, every second. So when I play the simulation, it's going to run through those points, and as if I hit that point, this is where it is at t equals 4 seconds, t equals 5 seconds, as this is where it was. Often what I want to do is I don't want these purple dots to appear there in the first place. What I want them to do is appear as the actual object arrives at that. And one of the ways to do that is to define the function, restrict its domain to be only valid for less than tf. So what that will do is allow this to go. Now this just runs from 0 to 1, 2, 3, I skipped 3 there, 3, 4, 5, so those are the locations. What you can do here is just do it like this. It recognizes this is an array that's as long as the time is. So if right here the array is just 1 element long, by the time it gets to 1 second, the array is 2 things long. By the time it gets to 2 seconds, it's a 3 element list, and it's keeping track of where those are. So this the 2 changes you had to make is we sort of had to describe the position of the particle in terms of a dummy variable t, and then create 2 different points. One point that actually tracks where the object is, and another one that tracks where the particle was each second of its time. All right.